Technology has continuously transformed the way we live, work, and think. But today, a groundbreaking innovation is emerging, a technological marvel that promises to redefine the limits of computation and its impact on society: quantum computing. Quantum computing is not just the next step in computing, it's a leap into a new dimension of problem solving. Unlike classical computers, which process information in bits, ones and zeros, quantum computers use quantum bits or qubits that can exist in multiple states simultaneously, thanks to the principles of superposition and entanglement. It allows quantum computers to perform complex calculation at speed unimaginably by even the most advanced classical supercomputers. Problems that would take countries to solve can now be tackled in mere hours or even seconds. The potential applications are vast. In healthcare, quantum computing could revolutionize drug discovery by simulating molecular interactions with pinpoint accuracy, saving years of research. In finance, it could optimize investment portfolios and risk analysis on a global scale. And in artificial intelligence, it holds the key to accelerating machine learning algorithms, making smarter and more responsive systems. Smart cities and autonomous vehicles could harness the power of quantum computing to process immense amounts of data in real time, ensuring safety, efficiency, and sustainability. From climate modeling to cryptography, quantum computing offers solutions to challenges previously deemed insurmountable. But like all groundbreaking technologies, quantum computing comes with challenges. Developing stable qubits, managing quantum decoherence, and creating quantum-resistant encryption are hurdles yet to be fully overcome. However, the progress made so far is promising. Quantum computing is the key to unlocking humans' greatest potential. As quantum computing transitions from the lab to the real world, it promises to empower individuals, transform industries, and address global challenges. This marvel of modern science is not just a technological breakthrough, it's a beacon of hope for a better tomorrow.
For a long time, the computing world relied mostly on x86 processors. These chips use what's called a complex instruction set computing architecture, which means they can handle many complex tasks at once. However, this comes with some downsides. They use more power, generate a lot of heat, and cost more to make. For people using portable devices like laptops, this created a trade-off. Yes, you could have great performance, but battery life would always be a worry, and you'd be on the lookout for power outlets more often than you'd like. Enter the ARM architecture, which is changing the game in the recent years. Unlike x86's complex instructions, ARM is built on something called the reduced instruction set computing, which uses simpler instructions that get executed one at a time in a quick, efficient way. This design means that ARM chips run faster and use less energy. Because they don't run as hot or use as much power, ARM processors are perfect for battery-operated devices, giving you much longer battery life. Another big plus is that ARM Holdings, the company that handles the licenses for ARM-based processors, licenses this design, which means companies like Apple and Qualcomm can customize the chips into what's called a system on a chip, by combining everything needed into a single chip. This flexibility makes ARM great not just for phones and tablets, but also for laptops and even supercomputers. Enter the 2020. And Apple led a new wave in ARM laptops by announcing their switch from Intel chips to their own custom ARM-based chips called the Apple Silicon starting in late 2020. This is big because of various reasons, namely the performance leap. Because before M1, x86 chips had dominated the high-performance computer world. While ARM was great for saving battery life, it traditionally had lower performance compared to high-end x86 CPUs. Apple completely changed its narrative. Apple took the efficient ARM design they had already invested heavily in for their iPhones and iPods, and tests of Apple's early ARM chips showed that they could rival or even outperform traditional Intel chips in performance. It also showed that the highly efficient ARM design could deliver top-tier performance without sacrificing battery life. In fact, the long battery life is perhaps one of the greatest impacts ARM-based computing devices had, and Apple's switch to ARM and the wider adoption of ARM chips in laptops have also huge benefits. User gets powerful machine that use less energy, which means definitely longer battery life, quieter operation, and cooler running devices without bulky fans. Well, at least for the case of Apple. And for them, making their own chips also cut production costs by as much as 60% over time. On a bigger scale, ARM's success is proving that this architecture can work not just in phones but in personal computers and data centers too. ARM is becoming a foundation for everyone, and everything from smart devices at the edge to the big infrastructure supporting AI and autonomous systems. Of course, ARM wasn't without its challenges. The biggest being was in its earliest form, ARM was software incompatible with many popular softwares. Even with Rosetta 2 doing a great job translating Intel apps for Mac, native app support for ARM wasn't immediate across the board. Also, although ARM is catching up, traditionally, its peak performance hasn't matched up the very highest x86 chips. A few years after Apple's initial success, with its M-series chips, Microsoft and hardware partners like Qualcomm have been pushing Windows on ARM devices using Snapdragon processors, like the Snapdragon X Elite and X Plus. Past attempts at Windows on ARM, such as Windows RT, failed because of weak hardware and little software support. This time, the new Snapdragon chips are powerful and include special units for AI tasks. Microsoft also improved how it translates the x86 software so that many applications can run right away. Snapdragon's laptops are competitive in terms of performance, the good pricing, and excellent battery life, which makes ARM a strong contender in the PC market. However, despite these advantages and good societal impacts, Snapdragon chips and Apple Silicon chips still don't beat the fact that they are always expensive and comes at the premium prices. ARM-based Windows laptops and Apple, for instance, remain pricey, which sits at around $1,000 in average, which could slow down their wider adoption compared to cheaper x86 options that many would ultimately still prefer.
In modern computing. Many people know it as what do you call this? Cryptocurrency, but to tell you, it is much more than that. Blockchain is basically a digital ledger or a digital record book, but the way it works is very different from the usual databases we know. Instead of storing data on a single server, blockchain spreads identical copies of data across many computers called nodes. Each time a transaction happens, that information is placed inside a block, and once a block is filled, it is linked to the previous one. This forms a chain of blocks, a blockchain. What makes this special is that once data is recorded, it becomes extremely difficult to alter. That's why blockchain is known for its transparency and security. Here's how the process actually works. First, a transaction is created. For example, someone sending digital money. That transaction is broadcast to all the nodes in the network. These nodes work together to verify if the transaction is valid, which is done through something called consensus. Once the majority of nodes agree that the transaction is legitimate, it gets added to a block. After that, the block is linked to the existing chain, and the updated version of the blockchain is shared across all nodes because everyone has the same copy. It becomes almost impossible to alter the data without being noticed. Blockchain has many important features. It is decentralized, transparent, and very hard to alter. It is secure and every transaction is traceable. These qualities make it reliable for more industries. Blockchain is used in various fields. The most popular use is cryptocurrency, like Bitcoin and Ethereum. It is also used for supply chain tracking, digital identities, voting systems, finance, and smart contracts. Blockchain matters because it reduces fraud, improves security, and removes the need for middlemen. It builds trust in digital transactions and makes processes more efficient and transparent. In conclusion, blockchain is more than just cryptocurrency. It is a powerful technology that is reshaping how data is stored, verified, and trusted. It will continue to influence the future of computing. So thank you for watching me discuss about blockchain, and I hope you have learned something. That's all. Goodbye.
With the world increasingly becoming more reliant on digital technology, methods to keep us interconnected will naturally develop as well. Released just in 2019, 5G has been the latest development in cellular network technology, building on its previous iteration, 4G, which introduced LTE and HD streaming. 5G provided speeds of up to 10 Gbps, significantly lower latency, which made it ideal for AR and VR. Though this may seem impressive, 5G technology was plagued with issues. 5G's fastest frequency, known as wave, had poor penetration to infrastructure, making portability a problem. 5G is also notorious for terrible battery optimization and uses up a lot of power. 5G cell towers are incredibly expensive to make, which can limit accessibility to rural areas. Enter 6G, the upcoming successor to 5G, which promises to fix the issues plaguing the technology. 6G research kickstarted almost immediately after 5G became widely available to the market, with major tech companies and governments investing heavily in the next leap of wireless communication. Expected to roll out around 2030, 6G aims not just to upgrade speeds, but to redefine how networks interact with the physical world. While 5G focused on connecting devices, 6G focuses on creating an intelligent, adaptive network capable of understanding and responding to real-time environments. One of the biggest promised improvements is its use of the terahertz frequencies, which are even faster than 5G's wave, due to the bigger bandwidth and support higher data rates, theoretically making it possible for 1 Tbps speeds, 1,000 times faster compared to 5G. Naturally, one would assume that since THZ has a shorter frequency, it will be even less penetrable compared to wave. This is where RIS, Reconfigurable Intelligent Surfaces, otherwise known as smart walls, come in. RIS can be placed on walls, buildings, and other surfaces to help redirect and amplify the weak signals and make them bend around corners or other hard-to-reach areas. 6G also plans to address the power consumption problem by using more energy-efficient hardware and AI-optimized network behavior. This means that the network will constantly adapt to reduce wasted energy by rerouting data to find the lowest power-consuming path or disabling unused antennae, meaning devices will be able to access high speeds without draining the battery as aggressively, and cell towers will be able to manage data traffic more intelligently to reduce energy waste. In terms of real-world applications, 6G is expected to enable near-instant communication with latency possibly as low as 1 millisecond. It can make holographic communication and immersive AR/VR experiences commonplace, allowing real-time 3D meetings, gaming, and training. Its ability to connect massive numbers of devices will support the Internet of Everything, smart cities, precision agriculture, and Industry 4.0 applications, including predictive maintenance and digital twins. Additionally, 6G will enhance mobile cloud computing, AI-driven networks, entertainment, and education, enabling holographic concerts, interactive learning, real-time translation, and gesture-controlled interfaces. By combining extreme speeds, massive device density, and intelligent network management, 6G promises a fully connected, immersive, and intelligent digital world. Overall, 6G aims to take everything 5G had tried to accomplish and make it more efficient, more intelligent, and more accessible. If 5G was about faster communication, 6G is about creating a fully interconnected digital ecosystem that blends physical and virtual spaces in real time.
In this clip, I'll give a short background of how artificial intelligence has been integrated with virtual and augmented reality. Together, these technologies create new possibilities for a brighter future by blending digital and physical worlds. This topic will also discuss the purpose and impact of AI, VR, and AR in transforming our future. Artificial intelligence is a trend that affects how we live, work, and play. It's a computer system that is built to mimic human intelligence and perform tasks faster and accurately than humans. Virtual reality, it fully isolates the user from the real world, replacing it with a simulated one that often uses controls and sensors to interact. Augmented reality enhances the real world's environment. The user remains aware and interacts with the real world. Artificial intelligence enhances virtual and augmented reality by powering features that delves into personalized experiences. Individuals with preferences can be recognized by the AI system, creating a custom environment for the user's unique experience. The fusion of artificial intelligence with virtual and augmented realities aims to create a more personalized and engaging user experience. This technology unlocks new possibilities for how humans could interact within the digital and physical realities. By allowing AI to work as the brain of virtual and augmented reality, it enables a real-time object recognition, natural user interaction, and adaptive environment. This is for the enhanced immersive, interactive, and realistic human experiences by allowing artificial intelligence, virtual and augmented reality capabilities to power and transform various fields such as entertainment, medicine, training, and education. Take a moment to close your eyes and imagine waking up inside a world where artificial intelligence, virtual reality, and augmented reality don't just exist, but bend and shape your reality at every command, breaking down every barrier to what you can become and achieve.